Again, it's a rich thing.
What is going on, guys? Welcome back to the Neural 9 channel. Today we're going to learn how to predict stock prices with neural networks in Python. So let us get right into it. Now, before we actually get into anything here, let me tell you, first of all, this video is not investing advice. And I'm not just saying this for legal purposes. It is literally not investing advice in any way. You shouldn't use this model to predict stock prices because it's not going to predict stock prices. It's going to be a recurrent neural network, an LSTM network, and it's going to use the last 60 days, let's say the last n days, and it's going to predict 1 day into the future. It's not going to project or to predict into the far future 50 days, 60 days, 2 years. It's just going to predict the next day based on 60 days. And you know, it might be better than guessing. It might be, but it doesn't have to be. So please don't use this to make investment decisions at all. This is more about learning how to use recurrent neural networks, more about learning about machine learning and neural networks and TensorFlow and Python programming than it is in any way about predicting stock prices. This video is not about predicting stock prices. It's called predicting stock prices. We're going to try to predict stock prices, but it's not going to be actually anything that you would want to use in your investment decisions. Now, of course, if you add a lot of more sophistication to that model, it might actually turn out to make decent results. But with what we're going to show in this video, we're going to see that it has some effect. So we're going to compare it. We're going to compare the predictions to the actual stock prices, and we're going to see that sometimes it's quite good, quote unquote. Sometimes it's not good at all. But all in all, this is not something that you would actually want to use. This is the first step to learning how to predict stock prices with machine learning, or attempting to predict stock prices with machine learning. This is not in any way investing advice or anything that you would want to use in your portfolio. So having said all that, we can start by importing some libraries and loading the data. So the first one is going to be numpy snp, import matplotlib.pyplot splt, import pandas spd, import pandas data reader as web, import datetime as dt, which is a core Python module, and then we're also going to say from sklearn.preprocessing import min max scalar, and from tensorflow.keras.models import the sequential model, and then from tensorflow.keras.layers we're going to have dense layers, we're going to have dropout layers, and we're going to have LSTM long short-term memory layers, and we need an import here. So if you don't have all of those libraries installed, you need to install them. Open up your command line, no matter if it's a Linux terminal or a Windows command line, and you say pip install numpy, pip install matplotlib, pip install pandas, pip install pandas dash data reader, and pip install tensorflow, and also pip install scikit dash learn. So that should be all of it. Maybe if you want to use candlestick charts, you can also import or install MPL Finance. I have a video on that on this channel as well. So this is those are the imports that we're going to need, and now we're going to load the data here, and we're going to use the pandas data reader to load the data. So we're going to first specify a company that we're interested in, let's say Facebook FB, and then we're going to say start equals dt.datetime, and here we can specify what timestamp, what time point we want to start the data from. So we can take the full data set as well, but we're going to say, okay, I'm interested in from 2012, 1st of January up until now. So end is dt.datetime. Or actually, maybe for the training data, we should not use up until now, but maybe something like 2020, 1st of January, like that. And now we're going to load the data by saying data equals wap.data reader. We're going to load the ticker symbol of the company. By the way, if you don't know the ticker symbols, just Google Amazon ticker symbol, Facebook ticker symbol, Apple, Tesla, whatever. And then you will find the ticker symbol. And then we're going to say we want this from the Yahoo Finance API from start to end date. So the next step is to prepare the data for the neural network. So prepare data. And for this, we're going to create a scaler first. So we're going to scale down all the values that we have so that they fit in between 0 and 1. So if we have the lowest price of $10 and the highest price of, I don't know, $620, what we're going to do is we're going to press all those values together so that they fit into 0 or in between 0 and 1. So we're going to say scalar equals min max scalar, feature range equals 0, 1. This is from the sklearn.preprocessing module. And then we're going to say scaled data equals scalar.fitTransform. And we're now not going to transform the whole data frame. We're only going to be interested in the closing price because we're not going to predict the opening price, the high price. We're going to predict the price of after the markets have closed. So we're going to predict the closing price here. And for this, we're going to say fitTransform data close dot values, and we're going to reshape them here because we need a particular format. So reshape -1, 1. And after that, we're going to define how many days into the future we want, or how many days we want to look into the past to predict the next day. By the way, here you can also use the adjusted close if you want it to be adjusted to stock splits. However, I'm going to use close because I feel like when I look at the data, it's always adjusted for stock splits. So also the closing value. But I might be wrong on that, so you might want to use adjusted close. I'm going to use close here. And then we're going to define prediction days. This is just going to be a number. How many days do I want to look into the past, or how many days do I want to base my prediction on? So how many days do I want to look back to decide what the price is going to be for the next day? In this case, I'm going to pick 60. You can pick more or less. And then what we're going to do is we're going to define two empty lists. So xtrain equals empty and ytrain equals empty. So we're going to prepare the training data here, and we're going to fill it up by saying for x in range. And we're going to start with prediction days. So we're going to start with 60, and we're going to go up until the length of the scaled data. So we're going to start counting from the 60th index, and we're going to go until the last index, so to say. Now, this is important because we're now going to say xtrain.append. So we're going to add a value to the xtrain with each iteration, and we're going to have this value be scaled data, and the index, or we're going to append 60 values and then the next value as a training example. Because this is labeled data, we're going to have the first 60 values that we already know, and then we also know the 61st value, but we need to prepare the 61st value here in a data set, or we need to prepare the whole training data in a way that we have 60 values and then the next value, so that our model can learn to predict what the next value is going to be. So we're going to say scaled data position x minus prediction days. This is why we start at prediction days, so that we don't have any negative values here up until x. So 60 values, 0, and then ytrain is going to be the 61st, so scale data x 0, like that. So we fill up those lists, then we're going to convert them into NumPy arrays. So xtrain and ytrain equals np.array xtrain np.array ytrain. And then we're going to reshape xtrain here so that it works with the neural network. So xtrain is going to be np.reshape, and we're going to reshape xtrain into the following format. We're going to say xtrain.shape 0, xtrain.shape 1, and 1. We're going to just add one additional dimension here. So now we can go ahead and actually start building the model. So build the model. And what we're going to do here is we're just going to say model equals sequential, basic neural network, and then we can specify the layers, model.add. We're going to always add one LSTM layer, a dropout layer, LSTM layer, dropout layer, LSTM layer, and another dropout layer. And then in the end, we're going to have the dense layer that is going to be just one unit, and this one unit is going to be the stock price prediction. So here we're going to say LSTM, and it's going to have units equal 50. those are just some numbers here. You can change those numbers and experiment around. Maybe you're going to get a better performance with less layers, with fewer layers, or with more layers, or with more units, and so on. But keep in mind that the more layers, the more units you add, the longer you're going to have to be training. And probably, I mean, not probably, but maybe you're also going to overfit if you use too many layers of sophistication here. So return sequences is going to be true for the LSTM, because an LSTM is a recurrent cell, so it's going to feed back the information. It's not going to just feed forward the information like an ordinary dense layer. And the input shape for this first layer is going to be, xtrain.shape, xtrain.shape 1 and 1, like that. So I hope this is syntactically correct here and I'm not doing any nonsense with the parentheses here. But after that, we're going to just say model.add dropout 0.2. And now we can actually go ahead and copy this. We just have to remove the input shape because we don't need another input shape here. And the rest stays the same. And then we can also add one more LSTM and one more dropout layer. Here we're not going to return the sequences anymore. And in the end, we have the dense layer. So we're going to say model.add dense. And this is just going to have 1 unit. This is going to be the prediction of the next price, closing, or actually that's called closing value. Then we're going to compile the model.compile. And the optimizer that we're going to use here is the atom optimizer. The loss function is the mean squared error. By the way, if you want to know more about those optimizers and the mathematics of the individual layers, like the more theoretical stuff, it's not going to be exciting. It's not going to be fast scripting and creating some exciting project. It's going to be mathematics. If you're interested in that content, let me know, because I don't want to explain loss functions and optimizers here in this video. I'm just going to show you how to do it. If you're interested in the theory behind it, let me know in the comment section. If enough people want it, I can make more theoretical content as well. Then we're going to fit them all on the training data. So xtrain, ytrain. We're going to feed it into 25 epochs, which means that the model is going to see the same data 24 times. And the batch size is going to be 32. Now, of course, you can also tweak those parameters here. So 32 batch size means that the model is going to see 32 units at once all the time. Now, we can optionally also go ahead and say model.save, and later on we can also say model.load. Actually, not model.load, but I think something like load model is a function from Keras. For this video, we're not going to do it. We're just going to fit it and immediately use it. And that's essentially how you define the model, how you build it, and how you train it. Now, before we get into the actual prediction, we're now going to try to figure out how well the model would perform on the past data. So we're not going to just predict the next future data that we don't know yet. We're going to see how well would this model perform based on the data that we already have. So if I always look at the last 60 days and predict the next day, what are the chances of this model being right? What's the accuracy? So we're going to start a new thing here, test the, actually let's not go uppercase, test the model accuracy on existing data. And for this, the first thing we're going to do is we're going to load some test data or prepare some test data. So here we're going to say test start equals dt.datetime. Now notice that this data has to be data that the model has not seen before. So remember up here we said we want the data up until 1st of January 2020. Today we have the 18th of January 2021. So we can say starting from the 21st of January up until now. So test end dt datetime now. This is the time range of the test data. So we have the data here, but the model has never seen that data. So we're going to see how well it performs on that data. And here we're going to say test data is just web.datareader, same company name, of course. Where's the auto completion? Don't I have company? Company, I have company. Okay, I'm going to write it out. Web.datareader company, Yahoo Finance API. test start and test end, like that. Now, what we're going to do with that data again is we need to get the prices, we need to scale the prices, we need to concatenate a full data set of the data that we want to predict on. So first of all, we're going to say the actual prices, not the predicted prices, but the actual real prices from the real stock market world are going to be test data closing values dot values. And then what we're going to do is we're going to create a total data set. So a data set that combines the training data and the test data. And for this, we're going to say pd or pandas.concatenate. And we're going to concatenate the closing data. Notice this is not scaled yet. So we're concatenating the close values of the data with the close values of the test data. And we're doing that on axis equals 0, like that. And then what we do is we say model inputs. This is what our model is going to see as an input so that it can predict the next price. We're going to say total data set, length of the total data set. So we're starting total data set minus length of the test data and minus prediction days, because we want to start as soon as possible. And then we're going up until the end and we're going to take the values. So just adding a colon and nothing after that means up until the end. And those model inputs, we're now going to reshape them. So we're going to say model inputs equals model inputs dot reshape. So again, -1, 1. And then we're going to scale it down with the scalar that we already have. So we're going to say model equals, or model inputs equals scalar dot transform model inputs, like that. So this is how we load the data, and we now have to prepare it. We already have prepared it. We need to now predict based on that data, based on the data that we have never seen before. We need to evaluate how accurate our model is, how well it performs. So let's go ahead and make some predictions. Make predictions on test data. And for this, we're going to say x test is an empty list, and we're going to repeat the process from above. We're going to say for x in range. And we're going to start again with prediction, days, and length, model inputs, +1 in this case, because we can't afford that. I mean, +1 is actually if you want to also have the newest one, I think. So we're going to not do +1 yet. And then we're going to say xtest dot append whatever we get here. So model inputs x minus prediction days. That's again why we started prediction days, to not get negative numbers up until x and 0 here. So we have that. And then what we do is we transform x test into, we don't have y test here, obviously, because we don't have, I mean, we have the actual stock prices, but we don't need to do it like that here. So x test equals np.array of x test. And then we also need to reshape it again. So x test, so that it has the same format. X test equals np.reshape x test.shape 0 x test.shape 1 and 1 additional dimension here. However, I think I forgot something. Oh yeah, actually we need to say x test here, and this is going to be a tuple of the shape. There you go. And now we can go ahead and just predict based on that x test data. So we're just going to say predictions, where actually if we have the actual prices, let's call this predicted prices. And we're going to say model.predict on x test. Now, what you need to take, or what you need to keep in mind here is that the predicted prices are now going to be scaled. So we need to reverse scale them. We need to inverse transform them. So we're going to say predicted prices equals scalar.inverse transform predicted prices. So now we're back using the same scalar. We're now back to the actual predicted prices here. Now, to make things more visual and more interesting, we're now going to plot the predictions instead of just looking at numbers so that we actually see how well the model performs. So we're going to plot the test predictions. This is not the actual prediction yet. And what we're going to do here is we're just going to say plt.plot, and we're going to plot the actual prices. We can also say, or actually let's just plot for now, and we're going to add the labels later on. So plt.plot actual prices, plt.plot the predicted prices. And we're going to see that we're going to have two lines now, and they're not going to be the same, obviously, because the prediction is not going to be 100% accurate. But actually, let's add the color here so that we know which one is which one. So black is going to be the actual price, and let's say color equals green is going to be the prediction. And here we're also going to say label and F actual company price, and we're going to copy that, and we're going to say not actual but predicted company price, and then we can also add a title, so plt title f string company share price. I'm not a design person, so you can care about the case and so on, or actually, come on, let's do it properly if we do it. So we're going to do title case here. And now we're also going to add a label. So X label is going to be time. We're not going to have dates here though. That's not too important since we're just predicting one day. So, and the Y label is going to be company stock, or actually share price. And then plt legend plt.show. Now we're going to run that script now, but I'm going to have to skip the training process because it's going to take some time. I'm just going to show you how it starts training, and then we're going to skip to the part where the training is done. I hope I don't have any mistakes here. So I get some warnings here, but after a while it starts with epoch 1 of 25. And then when we see the progress, we can skip this here. And you can see it works now. So I'm going to skip the video here, and I'm going to come back to you once the training is done. All right, so the training is now done and the plotting as well. You can see that the results are kind of fine, I would say. They're not accurate, but it's saying that's actually going to be lower. I think, you know, if the model predicts that the price is going to be lower than it actually is, as long as it's not too different, I think it's actually better than if it overestimates. However, again, keep in mind, we're looking at 60 days to predict one day. It's like, you know, if you flip a coin, maybe you're going to get worse results. Or actually flipping a coin is maybe not a good analogy because we don't have 0 or 1, but we have multiple values that we can choose here. But again, it's not too impressive to have this accuracy if you're just predicting one day into the future. We could also change them all in a way that it feeds back its own data into itself in terms of, you know, it looks at the last 60 days, predicts one day, then it looks at the last 59 days plus the one predicted day, and after 60 iterations, it's no longer looking at actual data, but on its own predicted data, and then the results are not going to be as good as this curve here. But still, again, this is not investing advice, but this is programming advice here, or programming education. And you can see that the curve is kind of fine. And we're now going to take a look at how we can predict the one day into the future that we don't know yet. So now the final part is predicting the future day. So predicting tomorrow or the next stock market day, the next day the stock market is open. So predict next day. And for this, we're going to create a real data list here. Actually, let me scroll down here a little bit so I'm not blocking this with the camera. No, I don't need a breakpoint here. Let's do it like that. So we're going to create a real data list. And this is going to be model inputs length dot, oh, not length dot, but length of model inputs +1 minus prediction days up until length of model inputs +1, 0, like that. Now I think it's maybe, where was this loop here? Actually, this doesn't matter, actually. Yeah, I don't think it matters. Now, if you want to plot it, you could also say +1 here, I think. But we're only interested in the numerical value. Actually, we're not interested in the plot because it's just 1 day. If it was 60 days into the future, maybe the plot is interesting, but one data point is not too interesting to plot. So we're going to say real data is that. Then real data is np.array of real data. And then real data is going to be reshaped as well. So np reshape the real data into the format of real data dot shape 0 real data dot shape 1 and 1 additional dimension here. And now what we can do is we can just go ahead and say print scalar dot inverse transform the real data. So we can first print the real data if we want to. I mean, that's optional. I don't even think that we need this. So let's just go ahead directly to the prediction. We're going to say prediction equals model.predict, and we're going to predict on the real data. So we're going to use the real data as the input, and then we're going to predict that one next day that we don't know about yet. So we're going to say prediction. The actual prediction then is just the scalar inverse transform on the prediction, and then we can say prediction is the actual prediction, but we need an f string. Oh, it's automatically making an f string out of it. Wow. So we can now run this again. I'm going to have to skip the training process again, but I'm going to show you the results in a second. All right, so after the training, we get this as a prediction tomorrow. Again, don't think that this is the actual stock price of Facebook tomorrow. This is not investing advice, but the model says it predicts that this is the price of tomorrow's Facebook stock. Let's look at the Yahoo Finance API. It's 251.36 right now. Markets are currently opened, I think. It's Monday. Yes, it should be opened. So this is the current stock price. I mean, it may be the case that tomorrow Facebook is going to be 252. It's not too unrealistic. But again, I wouldn't bet on it just because the neural network says it is. All right, so last but not least, we're going to look at a comparison between different companies here because I tried to predict stock price for those companies using this model. Notice, however, that here I only used the data from 2018 up until now because I didn't want to train the models for too long. And you can see, for example, the Tesla share price is not well predicted at all. You can see the actual stock price is up here, and you can see that here we have a flat line in the prediction. Looking at Goldman Sachs, it looks way better, but you should not be misled by that line. Just because it fits kind of well, we're not doing classification here, right? We're not training a polynomial regression here so that we have, I don't know, the right clusters. We're actually trying to predict the stock price. So if the green line is kind of correct, but after the black line, that does not mean that the model is predicting it well, because this means that the stock price already fell and then the model said it's going to fall. So actually, when the stock price is down here, the model thinks it's going to be here. So don't be misled just because the graph is kind of the same. If you decrease the 60 days to, I don't know, 10 or 20 days, you're going to be more sensitive to short-term fluctuations. If you increase it, you're going to look more for the long-term stuff. So you can also see the Twitter share, kind of fine. You can see the Facebook share. I mean, not that fine, but still okay. And then the Apple share is also, I mean, here it's over predicting, so it says it's going to be here, but it's actually not here yet. I mean, this is probably even a pretty good line because it's always predicting before stuff actually happens. So that's probably the most impressive result here. But yeah, again, take it with a grain of salt. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.